All right. Now, the last review, we had finished number 15. So, number 16, Savannah just got contact lenses. Her doctor said she can wear them 2 hours the first day and then increase the length of time by 30 minutes each day. If this pattern continues, which formula would not be appropriate to determine the length of time in either minutes or hours that she could wear her contact lenses on the nth day? All right. So we have an arithmetic sequence. It goes up by a constant amount, 30 minutes. Now just be careful. This mixes up hours and minutes. So maybe we could use 120 hours like this and then add on 30 minutes each day. So this one's okay. The one we want equals the one before it plus 30 minutes. Day 1, 120 minutes. That's 2 hours. 2 times 6. So that one's good. Which one is not appropriate? So this one stays in hours. And these are recursive formulas here. So this one stays in hours. And we have the first day, 2 hours. Yep. And then the day we want equals the day before it plus a half hour, which is what 30 minutes is. That one's good. Those were recursive because the one you want depended on the one right before it. Now, number 2, okay, so they're using the formula AN equals A1 plus N minus 1 D. A1 was 120 plus N minus 1 times 30. So we distribute 120 plus 30n minus 30. 120 minus 30, 90. So that one works. Oh, I guess I went out of order. That one's 3. Oh, well. Now this one. We have AN equals A1 plus N minus 1D again. A1 looks like we are using hours this time, so 2 plus N minus 1 times a half hour, 0.5. Excuse me. Excuse me. So 2 plus 0.5N. So we got the 0.5N, but it's a minus here. So that should have been 2 minus a half, which would be 1.5. This one cannot be used. Let me zoom in here. Hopefully you can see that one. Stupid autofocus doesn't work very well. Oh, and there's the itsy bitsy spider right there. All right. We want to find the inverse. Everything's so sticky. We want to find the inverse. So we'll drop the of x part. We'll switch f and x. Now, normally we got to solve, and that would require a logarithm like what we have here. But we could do that. It would be more complicated. Let's just go with the definition of the logarithm. Base, answer, exponent. And then we'll stick the -1 on it. So log base A equals the inverse. There we go. Again, you could take the logarithm there. It makes it more complicated. We'll just stick with base, answer, exponent, the acronym that everybody giggled at. Oh boy. All right. Now, 18, Kellyanne has $20,000 to invest. She puts half the money, so $10,000. That grows at an annual rate of 9.9% compounded monthly. At the same time, she puts the other half into account, which grows continuously at a rate of 0.8%. Okay, well, once, twice, there we go. And here's the form for the continually, or excuse me, not the continually, the compounded monthly or daily or whatever like that. So the starting amount was 10,000. 1 plus 0.009. It's monthly, so that's 12. And then to the 12t. So let's just check out what that works out to be inside our parentheses here. 0.00075, the 12th t power. It's got to be that one. And this one's correct as well. Once, twice, 0.008. And this one's the A0 times E to the RT. And she split it in half, so both start out with 10,000. There we go. Which graph represents a polynomial that contains this as a factor? It doesn't say it's an x squared. It says that this is a factor of some higher power polynomial, higher degree. Now, if this is a factor, we could factor it further, and we get x equals -1 as a repeated root. Now, we said when it repeats like that, it just bounces off. It doesn't actually cross. Choice 1. Oh, geez. There we go. As I was saying, when you have the factor repeat, it doesn't cross. It just bounces off. So it hits x equals -1, but does not cross. Okay. Sodium iodide 131. We're not going to use that 131. It's part of the name. Used to treat is used, that should say, to treat certain medical conditions, and has a half-life of 1.8 hours. Oh, excuse me, they were right. Sodium iodide used to treat certain medical conditions has a half-life of 1.8 hours. The data table below shows the amount of sodium iodide 131 round near 1,000 as the dose fades over time. All right, let's check this out. We'll put the one we want, or excuse me, we'll pick one, divide it by the one before it. Yeah, it's a half. Let's just see, let's verify that this is geometric. Yeah, that's what we got. So the rate is indeed a half. It's being multiplied by a half each time. So we go then, we want 18 hours. And we have AN equals A1 times R to the n minus 1 power. That's the formula from the formula sheet for geometric. We want the 19th, or excuse me, we want the 18th one. So the first one, 139 times 0.5 to the 18 minus 1 power. 139 times 0.5 to the, that's 17. Oh, you can't see it. 0.00106.001. There we go. Okay. Now, it's been a little while here. We have to reduce this down. We'll factor the top and factor the bottom. X's cross out. They cancel out. So we got x minus 4 over 2. Now, let's think. Okay, if we divide that, that'd be x over 2, and then 4 divided by 2 is 2. So that one's good. This is what we got, so that's definitely good. Now, the third one, how do we subtract? We get a common denominator, it's got it, then we just subtract. X minus 1 minus 3, negative 1 minus 3 is minus 4, and then we keep that denominator. So these are all the same. It's all of them. This is kind of a weird one. Instead of manipulating our answer, we're going to manipulate this. Minus 1 minus 3 is minus 4. Then we're good. Okay. Now, f is a polynomial. It's a quadratic. And it opens upright because this is positive. So that means if we find, let me see here, if we type this into our calculator, we get, let's clear that out, 4x squared plus 6x minus 3. Change my zoom back to standard here and see what we got. There we go. We can see it right from our graphing calculator. The minimum would be at negative 1. Well, actually, excuse me. I think this one's off here. So let's go back to second calc. Let's find our minimum. Put this on the left side. Put this on the right side. Then just hit enter again. So the minimum, type that in there. No, I didn't. That's weird. Let's see this again. Yeah, that's weird. I think it said a different answer last time. Huh. Anyway, the minimum value here, x equals negative 0.75. The difference between the maximum of p, the maximum of p is 5, and the minimum of f, 5 minus negative 0.75. Oh, geez. We want the minimum value, not the minimum x. My bad. Sorry, I'm trying to hurry to get this one done. Let's try this again. 5 minus negative 5 1/4. It's 5 plus 5 1/4. 10. Sorry about the confusion on that one. A little bit of a glitch in my brain on that one. All right. Number 23. The scores on a mathematics college entry exam are normally distributed with a mean of 68 and a standard deviation of 7.2. Students scoring higher than one standard deviation above the mean will not be enrolled in the mathematics tutoring program. How many of the 750 incoming students can be expected to be enrolled? All right. So if you score higher than one standard deviation, you're not enrolled. That means if you score lower than one standard deviation above the mean, so here we go, 68 plus 7.2, that's 75.2. This or lower will have to be enrolled. So I'll quit out of my graph here. Second distra, choice 2. The lowest score you can get would be a 0, 75.2. Then our average is 68, excuse me. 7.2 is the standard deviation. Paste that in. Now that's the proportion, but we want the number of, there we go, now you can see. We want the number of, so times 750, 631. And 24. There's no way to solve this using our algebra. So we have to plot both sides. So alpha y equals choice 1. We get 1 over 1 minus x squared. And then the other one, negative math over to num abs 3x minus 2 plus 5. Graph it. Let's see what happens. Ooh, that first one's weird, isn't it? Solutions are where they intersect. Now, luckily, it doesn't ask us for all of them, but how many exist? 1, 2, 3, 4. They intersect 4 times right on the 10 by 10 window. Oh boy, this one's a treat. Justify why this is equivalent to that. Raise over root. This is x to the 2/3, y to the 5/3. And then this is x to the 3/4 and y to the 4/4. Wow, y to the 4/4, that's 1. I'm just going to change that to 1. On the real regions, write it out again and change it to 1. Now we're dividing, so we're going to subtract our exponents. 2/3 minus 3/4. 2/3 over minus alpha y equals choice 1 3/4, negative 1/12. And then 5/3 minus 1, alpha y equals choice 1 5/3 minus 1, y to the 2/3. Using properties of rational exponent. So this is the root, and that goes on the denominator, raise over root. And that's the numerator or the top. You could say top of the fraction or whatever. So that's how we changed it to those. And then when you divide, subtract exponents. (26) The zeros of a quartic, 4th power. So the end's got to point the same way. Either both point up or both point down. The polynomial are 2, -2, 4, and -4. Okay, so there's -2. There's -4. There's 2. There's 4. This is just a possible sketch. So as long as we point the same way, and I'll have them both pointing down. We'll go up and over, and then back down, up and over, and there we go. All they got to do is point the same way at the ends. Could point them up if I wanted. Aaron and Krista, we're working on cubing binomials for a math homework. Aaron believed they could save time with a shortcut. Does Aaron's shortcut always work? I mean, really, we should just say no, because our teacher always says you just can't do that right there. But let's see. A squared, AB plus another AB. It's really BA, but we can swap that plus B squared. So that's A squared. There's two of those, so 2AB plus B squared. Now we're going to multiply that by A plus B, and I'll just put that first, makes it neater. A cubed plus 2A squared B plus AB squared, then plus BA squared plus 2AB squared. Again, B times just that B bumps that up. Those others stay the same. And then B cubed. No, not the same. Not even close. Okay, the probability that a resident of a housing community opposes spending money for community on involved improvement on plumbing is 0.8. So we'll call that the probability of opposing plumbing. Point 0.8. The probability that a resident favors spending money on improving walkways, given that the resident opposes spending money on plumbing issues, is 0.85. Oh, all right, let's see here. The probability that a resident favors, I'm going to say, walkways, given opposes plumbing, is 0.85. Determine the probability that a randomly selected resident opposes spending money on plumbing and favors spending money on walkways. Jeez. Well, for this, we got to go to the formula for conditional probability if it's not out of the table. And I'll just use A and B here. Now, the conditional, the given, if you have to use a formula, if it's not a table question, it's the and divided by the second one. So that's going to kind of work out for us here. That means for our amazing example, probability that they favor walkways and oppose plumbing, all over the second one, oppose plumbing. We want to solve for the and. That's what it asks us, the and. So I want this. So I'm going to multiply by the probability of opposing plumbing. For God's sakes. Luckily, this is what they give us here. So all we got to do is multiply those two numbers. Equals our answer. 0.8 times 0.85. 0.068. That's the answer we want. Easy question. Of course, they got to make it wordy like that and make it ridiculous. But anyway, I've run out of time for today. I will finish this and I will post both of them since I canceled review the other night.